counting something, if we're to generalize as well, yeah, sure.
When you need to perform one simple task over and over.
Yeah, so essentially if we're performing the same task like multiple times. Another way that I can usually remember this is if you have like the same line of code, like almost the same, if you have mostly the same line of code multiple times. So one example is when we were trying to cin stuff into an array, and we said like cin to words 0, cin into words 1, cin into words 2. Those lines are all pretty much identical except for the 0, 1, 2. So that's generally an indication that you can use a loop, and the parts that's changing, that's what you set as your variable in the for loop. Yep. Okay, so performing the same task multiple times. When might you use like an if, else statement?
Maybe when there's ranges, there's like a second, if it has to be a certain range, something happen.
Yeah, so like if the code is going to be doing different things, essentially, like with if else, I sometimes see people confuse when to use if else versus when to use a loop. Loops are if the same thing is happening and it's just repeating, then we use a loop. If else is if in our code different things happen and we need to do different things in option A or in option B. And you can combine them. Like if something repeats, you can put the if else statement inside of there as well. All right, any questions here? Okay. So we talked about while loops versus for loops. In the while loop, they both use the same structure. So what is like this statement here called? The int counter equals 1. Yep, initialization. So that's where we define the variable and we set it equal to something. What is this counter less than or equal to 3? Condition. So the loop is going to keep running while the condition is true. And then what is this bottom part? Counter equals counter plus 1. The update. If we don't update here, we're going to have an infinite loop. The nice thing with for loops are all 3 of those are required in the for loop. And if you don't include one, your code's not going to run. So the while loop, sometimes we had problems with infinite loops. With for loops, you generally run into less problems like that. The main thing is just your condition needs to become false at some point. Okay? But yeah, as we mentioned, initialization, condition, update. While loops and for loops have all the same components. With for loops, we just put them all on the same line. Where do the semicolons go in the for loop? Yeah, so kind of after each statement, but not after the last one. So you're going to have 2 semicolons total in a for loop. Questions here? Okay, the for loop execution. I think people kind of intuitively know this, so if it's easier for you to just think of your own examples, that's fine. If we're to formally explain it, initialization runs once. Why does it not run every time the for loop iterates? Yeah, like the initialization, we just want to set it once. If we always set counter back to 1 every time the loop ran, we would have an infinite loop because then counter would never become greater than 3 here. So the initialization runs once, then we check the condition, we run the code, we update. Looks very much like a while loop. Notice that the update is the last thing to happen before the next run of the loop. Okay? Okay. I think the most common mistake I've still been seeing in for loops is the counting down problems. I think people have gotten really good at counting up, especially with like getting the index of an array. People are good at starting that at 0, going less than the size, increasing by 1. That takes care of most loops. Sometimes though, we might want to count down. So in this case, the microwave countdown problem, we saw it a few weeks ago when we covered this the first time. We're starting the time at 15, and we want it to count down. And then at some point, we want it to say, your food is ready. So first off, what can we put as our initialization statement? Yep, and we need a data type. Yeah, int or double maybe could have worked as well, but we'll go with int time equals 15. The condition, I think, is what gets people. Yeah, so not equal to 0, because if we did equal to 0, the loop would never run. It has to be greater than 0. That way, once it hits 0, then it exits the loop and it will print out your food is ready. And then what is the update? Cool. Yeah, you can do minus equals 1, you can do time equals time minus 1, you can do time minus minus. All three of those do the same thing. We had a array problem that was like, get 6 words into an array, then print them in reverse. And for that problem, it's essentially start the index at the back of the array, like at size minus 1. Decrease size by 1 each time until that index is greater than or equal to 0. And then you can just see out your words of index. And it would start with words of 5, words of 4, words of 3, words of 2, words of 1, words of 0, and then it will exit. That's an example of a countdown problem. Questions there? Okay, for loop versus while loop. When to use each one?
For loop is for counting, and while loop is for validation.
Yeah, so generally, you could use a while loop for counting problems. We saw it like with this Morehouse example here. Like technically you could do this with a while loop. Typically though, the standard is if you're doing a counting problem, you're going to be using a for loop. And the two reasons why are, first, it keeps everything related to the loop on the same line, so it's easier to read the code. Second, it ensures the variable updates at the end of the loop. So it results in fewer errors than if you were to try to do this with a while loop. The case why we did learn about while loops though is for validation problems. So if we don't know how many times the loop is going to run, then we need to use a while loop. And so examples for this would be stuff like Wordle, when we check while the guess doesn't equal answer and num guesses is less than 6. Then we keep running the code. Questions here? All right, runtime analysis. I put one homework problem on runtime analysis. I only saw about 50% completion. I'd encourage you to go back and do that problem. Like there will be a runtime analysis problem on the final exam. We'll review it here. So runtime analysis, it measures how quick or efficient an algorithm is in the worst case. And we use what's called big O notation to essentially put it relative to a general input size n. Okay? So in this example, I know the code is Python, but we could imagine it being similar to C++. This first line here, x equals 5 plus 15 times 20. Does that depend on any input size? No. So in this case, what would the big O of that be? O of 1. So that's what we call constant time. It doesn't matter. Like even if we had an array with 1,000,000 elements, this top line is always going to just run one time. So we call it O of 1. This for loop here, it prints out x from 0 to n. How many times is this print x going to run? N times. So what would the big O of this be? O of n. And then this one, we have a nested for loop. They both run from 0 to n. So how many times does this print x times y run? Yeah. So we have O of 1, O of n squared. What is the overall runtime? Yeah, so you just take the biggest one because the others won't matter. Like if n is 1,000,000, there's no difference between 1,000,000 versus 1,000,001 in the grand scheme of things. Yeah.
How is the first line O of 1?
O of 1 is because this x equals 5 plus 15 times 20. It only runs one time, no matter how big n is. So it's what we call constant. One thing I want to clarify, I don't want people to think just because every time you see a for loop, it's always going to be O of n. I'll show an example where a for loop would be something else. If we had, we'll have like int I equals 64. So in this case, like n is kind of like 64. Okay, you set n generally to what the for loop is. So 64, we'll say I is greater than or equal to 0, or we'll say greater than or equal to 2, and then I equals I divided by 2. And we print I in here. See out I. How many times is this for loop going to run? We'll give people a few seconds to think about it.
You're dividing I by 2 each time.
So you're dividing by 2 each time. So let's think about what's going to be printed out. Like the first time this loop runs, what's going to be printed?
64.
64. Then the next time the loop runs,
Oh, then it would be
32.
Okay, and then 2, and then when it's 1, it's no longer going to be greater than or equal to 2. So how many times did this loop run?
6.
1, 2, 3, 4, 7 times. Okay. So this loop ran 7 times. So it's not going to be O of n. Like if we were just doing I minus equals 1, then this code would have ran 64 times, and we would have said the runtime for this is O of n. In this case, for problems where the problem always gets divided in 2 each time, does anyone remember what that big O was? It's what we call O of log n. Okay? So for the exam, I would test you on these 3 plus O of log n. And O of log n is when the problem divides in half each time. So an example we saw in the real world was binary search. It's when I had a number between like 1 and 100, and I had you all guess what my number was. You all first guessed like 50, and I was like, it's lower. Then you guessed 25, and I was like, it's higher. Then you guessed 33. Every time we're shrinking the problem in half, like the searchable area in half. So binary search is a O of log n algorithm. Questions here? Okay. So again, the way I like to think about big O notation is relative to n, how many lines of code is going to run in your program. Also, one last clarification. Do people get how we said, like, in this problem, like, n was 64? Like, this is just a specific example. We could have had I start off at, like, 1,000, and then this code still would have run, like, log of 1,000. So n is kind of just a way to say, like, roughly whatever our starting input size is. Yep. Okay. Cool. Any questions on loops or big O notation? All right, let's recap arrays. What's the definition of a variable? What are the key components? Yep. So it's like a placeholder for data, not the data itself. What else? Uniquely named. Sweet. So uniquely named, it's a storage location, holds 1 piece of data. What's the difference with arrays? Yeah, essentially the same definition. It's still just referencing data. It's not the actual data. But the key part is that it can hold multiple pieces of data. Okay. So array definition, I know we've seen this slide a bunch. Hopefully it's hammered in. Start with the data type. Whatever the name of the array is, you get to choose this. Make sure you use lower camel case. And then the size of the array. Every other time we use these square brackets, it's going to refer to what?
It's the size.
Yeah, so the first time it's the size, what is it every other time?
The index.
Yeah, to get a specific element. Okay, so if we wanted to define just like the name, like a variable that holds the name of a planet, what would the definition look like? Yep, you just put the data type and then the name. And then if we wanted to do an array of 8 planets, yep, string planets 8, cool. Array initialization, like we could define the array like this, and then we could say planets of 0 is equal to Mercury, planets of 1 is equal to Venus, planets of 2 is equal to Earth. That would be a little bit tedious. Instead, you can do it all on the same line. So it still looks a lot like the definition. You have the data type, the name, the size, but then you put in equals, and in the curly braces, you put the different values that you want. So 25, 9, and 18 in this case. If we wanted to initialize a variable, what would it look like? Yeah, so we still need the name, so string planet equals Earth. I don't know if I ever formally taught variable initialization. I've kind of been using it in examples. Like you can do both of these on the same line. You could have either said like string planet semicolon, and then on the next line say planet is equal to Earth, or you can just combine them into one line if you already know what the value is going to be to start. Okay? And then the array of any 3 planets would look a lot like the previous one, string planets at 3, but now it's equal to, and whatever values we want in here. Questions here? Okay, array modification. I switched up the problem a little bit from what we saw before. Ages of 3 equal to 25, 9, and 18. Ages of 1 equal to 4. What's going to happen?
9
9 times 4.
Okay. And then what happens on this line?
18 times 16.
Yeah, so 18 minus 2 is 16. So ages of 2 is going to be equal to 16. What if we said ages of 3 is equal to 2? What's going to happen? Okay, why will it not work? Yep, you'll get an index out of bounds error. On EdStem, you might see this as a segmentation fault or memory error. Cool. But as we said, ages of 1, the 9 changes to a 4, the 18 changes to a 16. Questions here? Okay. Let's talk a little bit in more detail about parallel arrays. I think still some, I don't know. All right. What is some, so first off, what do I mean by parallel arrays?
Like arrays that like relate to each other.
Yeah, essentially if we have multiple different arrays and they relate to each other in some way, what are some of the characteristics we need? What do we need to be true about them? Yeah, like there has to be like the relationship, there has to be some relationship between the indexes. So for example, if we had like array 1 that looked like this, 8 and 3, and then we had another one that looked like this, 4, 2, 1. What would be the problem here?
They don't have the same number.
Yeah, the size. Like they need to be the same size if we're doing columns with parallel arrays. Like all arrays need to be the same length, and there has to be some relationship between the indexes. And the reason why there has to be some relationship here is that we're just going to use one for loop. And so if we said like, go from index equal to 0 up to index equals 2, when we try to get this array's index 2, there's going to be an error. So we need them to both be the same size, and there has to be some relationship. The example we did in class is if we wanted to calculate the area of multiple rectangles. Essentially, what's the relationship between these two arrays?
They're both the same size.
Okay, they're both the same size. And like, what does index 0 represent for both of these?
Like the first place we would use.
Yeah, it's like the first rectangle. Like we can think of this as rectangle 0 has length 3 and width 2. Rectangle 1 has length 1 and width 4. Right? So do people see that relationship between them? Okay. So if we wanted to get the areas for all of these rectangles, like what should the areas be for this first one, or the 0th rectangle? 6, and then, okay, and then 6. So how can we set up the for loop to do this? Okay.
It's got to be was it less than or equal to 2?
Yep, less than or equal to 2, or we say less than the size usually, so less than 3. And then the update. Cool. So index equals 0, index less than 3, index plus equals 1. Again, this only works because both of them are size 3. If one of them was size 2, then this code would break because we'd have an index out of bounds. And then areas of index. So the first time this loop runs, it's going to be areas of 0 is equal to something, then areas of 1 is equal to something, then areas of 2 is equal to something. What is the something we can put on the other side? Yeah. So as we said, it's like lengths of 0 times widths of 0. That's going to be 6, and that's areas of 0. Lengths of 1 times widths of 1. That's going to be areas of 1. Right? I guess the reason why I think there's maybe I'll put one more practice problem for this is we had the grading exam problem on one of the homeworks where we had an array of guesses and an array of answers. What was the relationship between those two arrays? Like, how could we tell how many guesses the user had correct? Yeah, like, so we had a homework problem where we had like an array of guesses. So if our top array is like guesses, and this one was answers, and it was like an array of chars, so we said this was like, they guessed A and C, and then the answers were like B and C. Like what percent did this person get correct? 50%. How did we know that?
Because one out of two of the guesses equals one out of two of them.
Yeah, essentially like we checked, does A equal B? No. Does C equal C? Yes. And so we could increase the number that they had correct. So in this case, we had like an if statement, and what goes in the if statement here?
If guess of index,
Yeah, so if like guesses of index is equal to what?
answer of index.
Answer of index. Right, and then in here we had something to like increase the number correct by 1.
Yeah.
That's the same as essentially what we did here. Like there's a relationship between each of the arrays, between index 0, index 1, index 2. Right? All right, questions here? All right, a separate class of problems. So we first talked about like one-dimensional arrays, right? This is all stuff just dealing with normal 1D arrays. Then we talked about parallel arrays. There's one other class of problems that we covered, which is the 2D arrays. The 2D arrays, to define it, we still put the data type, we put the name. This time, like, what does the 3 represent and what does the 2 represent? Yep, and which one's, the 3 is?
Rows.
Yeah, so it's number of rows, then number of columns. So this would create an array with how many elements total? 6, and you can get that by multiplying the rows times the columns. So right now, it would look like this with question marks in all the boxes. If we wanted to define our own 2D arrays, we did this example with the 8x8 chessboard, what would it look like? And each element will hold the name of the piece.
Pieces, 8.
Okay, and we're missing one thing there.
8. String?
So in this case, we'll do string because it's going to hold the name. So yeah, it's going to be like the element, so we'd do like string. You could call it pieces, I called it board, but 8 and 8. Okay, and then over a 5-year period, the rainfall per month. So this will be something like 5.4 inches of rain in November.
So double
Mm-hmm.
the rainfall,
Mm-hmm.
and maybe 12.
Yeah, 12.5 or 5.12. This one's personal preference. On an exam, I'd make it clear what should be the rows, what should be the columns. Or if I don't make it clear, you can do it either way. Okay. Questions here? Okay, if we want to modify a 2D array, so first off, with initialization, you put the rows in brackets. So it's like a 2D array is essentially an array of arrays. So we have these different array elements here. The first array element is the row 9084, which maps here, 9084. The next row is 9888, 9888, and then 62 and 100. So that's what it would look like to initialize a 2D array. And if we wanted to say scores of 2, 0 equals 75, what's going to change here?
Is that 62? You're going to change 75?
Okay, how did we get 62?
Because you go to the, what is that, project 2?
Student 2, yeah, like row 2 here. Okay,
And then you go to the 0 to
Yeah.
62.
yeah, so again, 2, 0 is like row 2, column 0. Rows are the horizontal, so we go down to the second horizontal row, the 0th vertical column. Okay? Cool. Questions here? So the 62 will change to a 75. Cool. All right. Recapping strategic 7s. Okay, so in groups, I'll have you share kind of what did you find worked, what didn't work, how did your player strategy do, and then we'll bring it back together to share like good strategies and findings. So I'll give groups like 2 to 3 minutes. You can discuss with the people around you.
Alright, so the game. I just try to make friends with all the time.
just like what was your final player strategy essentially? Like what did you try to do?
Tried to get to
While the
I rolled, if I rolled 7, I think like 20, I rolled 7,
Yeah.
and then from there, I would play. Was at 150, was below 150.
I kind of did it. Otherwise, I have my double turn score power.
I think that's why it's too much.
Yeah, we did.
Yeah.
For hard blood, we did add in code because that's how I check if they got it. I would need to. I would but yeah, we could have even made like a harder question that
trying to get started late. I think my number was like 38.
So it's all so that's essentially like we have to sum together 3 different variables. So it's like the user score plus the
I didn't
score
think
plus the current one and stuff. If one three added together greater than 200, then we would want to say return true in the should enter.
Okay.
That I added for the should and turn was like
Turn score, user score,
like there
and
was an
okay,
and
and total score.
Yeah, well, so the users, yeah,
to give
because your user score is like what's permanently on the page. So it would be like 180. Your turn score could be like 16, and then if you roll a 5 on the dice, you kind of have to add that 16 and 5 together to get what your actual score would be at the end of the turn. While it being at 16.
Oh,
by step.
I could start that.
That just did made it do something with the hard body. That like that was a good. I could have done a little better.
I think I did like user score greater than 200.
But that's your best.
So
No, I did user score plus total score greater than 200. I was that one.
it would have been super pretty good if you were missing the whole sum.
Yeah.
Like in our, I was really trying to emphasize this class. Like we have the score on the calculator plus like what's on the dice. We asked you what your group is going to be when those two are set. And I think in class people were just like automatically adding them together. The code had to keep it separate. Okay, let's bring it back. Okay. So what were some things people found worked or that like greatly increased like their win percentage? What are some things? Yeah.
That you should end the turn if the current roll sum is greater than 10.
If the current roll sum is greater than 10. So that's just based on the dice roll, right? When you're playing the game in class, were you doing it based on the dice roll or were you doing it more based on like your overall turn score?
Turn score.
Yeah, so like roll sum could be okay. I think more when people were seeing bigger increases in winning percentages was basing the should end turn on the turn score. Which if you think about how what this like project was trying to get you to do was we were playing the game in class, but it was trying to get you to think like a computer. Like when you're playing in class, your mind is actually doing a ton of if statements. You're just not realizing it because it's so fast. This game is kind of trying to take those if statements and put it into code. And I think most students, when they were playing the game in class, it would be based on the turn score. Like once you got like 25 points or 30 points, then people are like, all right, now I'm risking a lot more, so I might end the turn. Okay? On turn score, and you kind of have to do turn score plus current roll sum to get like your actual, like what you would get for that round. Okay, what else?
Like at the beginning of the game, if you didn't use your go,
Mm-hmm.
if your turn score is like over, like it should be
Mhm.
something you go like at the start of the game.
Yeah, so, and were you doing this in like your should end turn function or in your double?
I'm doing that in my should use
Okay, should use double turn score. Like double on a big value. So if you said though in your should double turn score if it's greater than or equal to 50, in a sense you then also had to make sure your should end turn also only ended turn if your score was greater than or equal to 50. Yeah, like they both have to be in tandem. I think the biggest win percentage change I saw in people's code was essentially using two different values in your should end turn. So like if you still have the double power up available, then maybe you end your turn when you get like 60 points. And then, because then if you double it, you get like 120. But if you have used your double power up, then maybe you only end your turn after you get 30 points. And you're a little bit more conservative to lock in points. I think that was like really taking people from like 40 to 50% up to like 70%. So kind of using the has double power up in should end turn function. So essentially having two different thresholds in your should end turn. A higher threshold if you still have the double power up available, a lower threshold if you have already used the power up. Okay. Other thoughts? Kadar? A catch-up mechanic. Okay. What does that look like?
Mine was if I was behind by 75 points, then I would roll to 75.
Okay. Like use a different threshold. Use a higher threshold.
And then I also had one that was if the bot was at 150 and I was over 100, then I would roll to victory essentially because I would be too far behind. I'd have to roll to try and win.
Okay. So based on opponent score, be more aggressive. Yep. Cool. All right. How about I was talking with Jakylin and Isaiah here. What were you guys discussing with the like 200 points end game?
Ending like what your score, either his time or like right when it's like over 200 on that roll.
Yeah. So for this one, we need to sum together three things. We need to sum together the user score plus the turn score plus the roll sum. If that sum is greater than or equal to 200, then we know we want to end the turn. Yep.
In addition to this, you also, if you have your double score, you want to be able to check that your double also qualifies.
Yeah. Also make sure it works with double. Yeah, so if you're at like 160 user score and you still have your double, then you really only need to get 20 points on the turn to get to 200 because you can double the 20 to get to 40. So making sure it works with that too. So there's a lot of different like if cases that when we play the game, we do subconsciously. It was trying to take all of those and put them into different if statements for this project. In terms of grading, that's going to be this week. Book an appointment. So bit.ly/googler.oh. Again, we were flexible with Wordle. In this case, it has to be graded by Friday, December 2nd. I would encourage you to book an appointment for earlier in the week. That way, if anything goes wrong or your Wi-Fi goes down, like you still have the opportunity to join a later appointment. If you put this off till Friday and something happens and you can't do the appointment, like we're kind of in trouble, right? So try to do it earlier. I'm meeting with the Googlers right after this class to get them to add more appointment slots. I know right now there aren't that many, but check again later today if there's nothing available right now, and there should be more spots. Share your documentation doc. So some of you have already emailed me or you emailed to my Morehouse. So if you did that, you're good. If you haven't yet, and especially if it's a Google Doc, you can just share with this email address. And then for your appointment, we're essentially going to be asking a lot about your documentation. So make sure you come prepared knowing like how did you start the strategies, what changes did you make over time, what strategies worked well for you, what changes didn't work well. Make sure you understand how the game state variables work. There's going to be some code comprehension questions. So like, what does the current roll sum represent? What does the user score represent? And then understand how your code works. So we're going to give you a scenario where this is the game state. What is your code going to do? And we're going to have you show us in your code what if statements are running to make your decision for whether to erase the roll, whether to double the score, whether to end the turn. I encourage you to take a photo of this slide to help you prepare for the meeting. Again, these bottom two are the main one. Make sure you have all your documentation ready. Bring that to the meeting as well. Questions here? If you did the project and you understand the project, like, you should do fine. If you need to brush up on your code and what you wrote in your documentation, do that before your meeting. Make sure you come on time. It's going to be a packed 20 minutes. We really need people to come right on time. That's part of the grading, punctuality. Okay? Any questions here? Okay. Again, bit.ly.googleroh. The OH is capital to go ahead and book your appointment. Okay, final part, recapping functions. Function definition, function is a block of code that can optionally take an input, does a specific task, can return an output. If a function doesn't return an output, what is the key return type word that we put?
Void.
Void. So instead of like double and then the name, you would put void. Functions are super useful because it can make the code simpler, and we can test each part separately. So the homework that's due today is Wordle with functions. Essentially, your main function is just going to look like this, maybe 10 lines of code. It's a lot simpler to digest compared to what you wrote initially for Wordle. And the nice thing is we can test each of these functions separately to make sure they all work before we put it all together in the main. Okay. If we wanted to create a function that checks if a letter is in the word, first off, what is the return type going to be for this function? Bool. So in this case, like, we're going to return true if the letter is in the word. We're going to return false if it's not. And then with parameters, when we're choosing what parameters to put in the function, it's what information do we need in order, in this example, to give the correct answer. And essentially every time someone calls our function isLetterInWord, they might give us different values. So what might change each time this function is called? Yeah. So index is always going to start at 0. Like, we're always going to start at 0 and go till the end of the word. So that's never, like, that's always going to be the same. So we can define that in the function. Yeah, like the guess are like essentially the word. So we need to know what the word is.
And then are you looking for a character?
Yeah, we also need like the letter that we're looking for. So it's like the letter that we're looking for and the word. So we could call this function with isLetterInWord, and we could pass in the letter A and ball. Or we could call the function again and we could pass in the letter C and the word truck. Right? Each time we call the function though, we might give it different parameters. And so that's why we need these two as input parameters. Questions here? Okay. In the isVotingAge function, we just need to know one thing. We need to know what the age is so that we can tell whether they're old enough to vote or not. Why is it okay for us to not have an else statement and just say return false here?
Because if age already isn't like, if age, because if you were to use like an else statement, then it wouldn't return anything, because if age isn't,
So an else statement would work. Like, the code would still work even if we did else return false. But there's a reason why this one would work even without the else.
It's like any condition that is in the if statement isn't true is false.
Yeah, like with functions, only one thing can be returned. So in this if statement, if the age is greater than or equal to 18, we're always going to return true, which means that if age isn't, and like we'd return true and we would exit. So we would never get to this line. The only way we get to this line is if this if statement is false. So if age is less than 18, then we know we can just automatically return false. A lot of you had this set up in your Strategic 7's final project. You had these if statements where you wanted to return true, and then you just put the line return false at the end. If none of the above were true, then by default, we know it's going to be false. Okay. All right, so that's all related to creating functions. The other half of functions is calling functions. So in this example, we're calculating the area of a circle. We call the function pow. It takes two parameters. We don't need to say what the data types are. We just give what the actual values are. So we call pow with the two parameters that it requires, radius, like the base and the exponent. If we want to call this function that we wrote, so we wrote calculate circle area, we want to get the result, what would go here?
The area equals, result equals calculate circle area, and then R in parentheses.
Yeah. So 2 things. Why do we not have to put like double radius here as well?
But it's already defined in the function.
Yeah. So when calculate circle area is called, this first parameter radius is just going to be equal to this value. And what's the value of R? So radius is going to be equal to 3. This code is going to run 3.14 times 3 squared. We're going to get like 28. Why do we store 28 in this double result? The 28.26 returned from calculate circle area.
You said what?
Yeah, like what if we just left it like this? Like we just called a function. This code would still run.
Well, you gotta put the values in there, right?
Yeah, like this will return 28.26, but if we don't store that anywhere, then we can't use it in the main function later. So we store the 28.26 in this variable result, so that later on the next line we can say the area is 28.26. If this was a void function, if this didn't return anything, then we don't need to store the result anywhere, because there's nothing returned.
So you could just put the function where the result is.
You could do that as well. Like if you were only going to use it in your main function once, you could have just said the area is, and then calculate circle area of R. If we were going to use result multiple times, then we would want to store it in a variable.
Okay.
Yeah. Cool. Questions here on calling functions? Okay. Final exam, 11 a.m. I think, Omar, you're technically in the 1 p.m. class, so yours would be 4 p.m. to 6 p.m. I think everyone else is in this section officially. So you have to come Tuesday, December 6th at 1 p.m. for final exam. You won't have any class conflicts at that time. Like this is the official final exam schedule for all of Morehouse. So it doesn't matter like what your schedule normally looks like. Tuesday, 1 p.m. to 3 p.m. you will be free on December 6th. Okay? Questions here? Okay, final exam topics. We came up with this as a class last time. Arrays, functions, loops. There'll be some debug, if, else statements, structs, big O notation. Like there aren't going to be any trick questions on the exam, but the exam's going to be hard. Like if there's a topic here that you don't know, I would encourage you to, like we have all the slides from all 37 lectures, and there's descriptions for all of them. So if you want to brush up on arrays or parallel arrays, 2D arrays, like just go and click on the slides of the YouTube video, take a second look, grab a note card on your way out. You may write front and back on the note card. I'd encourage you to put stuff that you don't know from the slides on there. Remaining assignments, top priority, meet with the Googler this week, so book your appointment, share your documentation with me. Essentially finish all the other assignments by December 4th to get credit. And then lab today at 5 p.m. is going to be going over, essentially if you haven't finished any assignments, come into lab and we'll go over those assignments. We also have office hours 3 to 5. Question?
Okay, so you don't have any classes on Friday or these labs are all optional?
Yeah, so there's no new material in the lab. It's just going to be if you haven't finished an assignment, we'll help you finish the assignment. And then Wednesday's class, I know it's going to be raining Wednesday. Still try to come in for Wednesday's lecture. We're going to be doing a practice final exam. The practice midterm was very close to the actual midterm. Likewise, this practice final will be pretty close to the actual final. Blake, question?
Is it just gonna be like a midterm where you would just hand
Yep. All right. Grab a note card on your way out if you don't have one. I'll get you. What's up?
Friday, you said it's optional?
There is no class Friday. Yeah. It's just the Wednesday one is, Wednesday we'll be doing the practice final, so come for that. Yep.
Please don't.